Good afternoon. A report is presented on the topic Comparison of Redux and React hooks methods in terms of performance. Authors Daria, Pronina and Iryna Kyrychenko from Kharkiv National University of Radioelectronics. The process of creating web applications has evolved and become easier over the years. Talking about state management, thousands of different libraries implement various approaches to managing the state of front-end applications, making it hard to decide on the correct method for a particular project. One of the disadvantages of having a wide variety of tool options for solving the same problem is the fact that there are no real standards that can be used when choosing technologies for the development. As a result, the chosen technologies may be not very appropriate to use in terms of performance. High-performance websites improve the user experience. In addition, the performance of the websites also impacts websites' position in Google search results. This makes a study on state management methods from performance point of view essential. The goal of the study is to compare Redux and React hooks methods for state management in React single-page applications and provide the future recommendations based on the obtained results. React library was chosen for the study. It is a declarative component-based library and one of the most flexible libraries for user interface creation. The flexibility of React in particular lies in the fact that for a long time it was positioned as a library that solves only the task of presentation, making it possible to build user interfaces in the form of a component tree. It is also very popular among the developers and has around 15 million of weekly downloads. There are several options for creating and delivering a user interface. The studies highlighted the shift towards single-page applications instead of the traditional approach of creating a multi-page application. The main goal of single-page applications is to offer faster transitions on user interactions and to make the web application feel more like a native application that is running locally on the device. In many senses, it is a local application, albeit one that is loaded from the internet rather than from local disk when it is launched. In order to study the impact of different approaches on the performance, a simple front-end application was created with the following functional requirements. In this way, implementing the same functional requirements with two different methods make it possible to compare them without any assumptions and result data modifications, since the experiment is carried out on the same data. The presentation part of the application, once implemented with React, remains unchanged during the study, while the state management is being implemented with React hooks and Redux approaches separately. Redux is a third-party library for state management that is used in front-end applications. At some point, it has become very popular. It has its advantages such as scalability, and it helps make maintaining the application state predictable. The main concept behind Redux is that the entire state of an application is stored in one central location. The official React bindings for Redux are implemented and provided with React Redux library. Using methods provided in this library, React components can be attached to the application store or to some part of it. The global state of the application is read-only. In order to make changes there, it is necessary to dispatch a corresponding action. Actions in Redux are plain objects that have type and payload. However, this is modified with the Redux Sync library, so the actions are transformed into asynchronous functions. Changes in the global state occur through pure functions. This means that these functions shouldn't have any side effects. All reducers as well as additional middlewares are combined into a store that is passed to the React application by the special component provider. For React hooks implementation, no other dependencies are required except the React library itself, with the version starting from 16.8. React hooks approach provides an opportunity to implement all the logic directly inside components, whether it is a basic operation with state, interaction with browser APIs, or network request. The straightforward approach at scale brings a lot of duplicated code, as well as constrains logic to specific components, resulting in the tightly coupled code. Although this can be avoided by creating and using custom hooks. Custom hook is a function that uses built-in React hooks in order to provide a more complex functionality. In such way, the encapsulation of all logic related to API or other state manipulators can be achieved. Built-in React hooks that were used use memo, use callback, use effect, use state. These hooks are designed for storing memoized values, callbacks, and simple component state data, as well as performance side effects. Memorization is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls and returning the cached result when the same inputs occur again. The custom hook use API was implemented. The API used for the research is RESTful, and therefore the API calls can be easily reused by only providing the entity name in configuration and a callback. The influence of the chosen state management approach can be observed both in the output code. In the case of a front-end application, this is the size of the JavaScript file, and measurements in the directly running application. Google has created a model called Web Vitals for providing development guidelines to developers in the process of designing and building web applications, which are extremely important for providing an adequate user experience on the web. Web Vitals is a useful tool for evaluating web applications' performance, though most of those metrics is not influenced by the state management approach, but with other parts of the front-end related part of the web application. Therefore, it was decided not to use Web Vitals directly, but they were taken into account. It was assumed that the most impact of the state manager choice can be observed on the build side and while user interacts with the page. The bigger build size, the more it takes for user device to download all the application files and launch it. Time that it took for page to load and become interactive is a very important metric as it affects the potential users significantly. Taking into account everything mentioned, the metrics displayed on the slide were defined for the comparison. Measurements regarding the code size of the project are shown in table. The following formula is used for calculation of the percentage delta in amount of code needed for implementing base methods for one entity both in the new project and in project with implemented other entities, where V1 is the size of code that was developed for implementing methods of the first entity in kilobytes, and V2 is the size of code for the second entity respectively. The results of calculations are presented in the table. The following formula is used for calculation of the reused code percentage, where V1 is the size of code that is used by both entities in kilobytes, and V2 is the total size of code for both entities. The results of calculations are presented in the table. Assuming that the following entities will take the same amount of code to be implemented as the second entity, the growth rate can be calculated by the following formula, where V1 is the total size of code for both entities in kilobytes, and V2 is the size of code for the first entity. The results of calculations are presented in the table. For measuring performance of the running web application, Chrome DevTools may be used. Chrome DevTools is an interactive dashboard that has a lot of different tools for web developers included, and it is built in the Chrome browser. The example of performance tab, Nauky, is shown on the slide. Among the presented tabs, the one called Performance may provide a lot of important information and shed some light on how it actually works under the hood. While storing application data with Redux or hooks, the memory of user's device is consumed. As there are many ways for storing optimization with different data structure and approaches, the required size for the same data in Redux and hooks isn't equal. The amount of memory was measured for different size of data stored in an array 10 times, and after that the mean value was calculated. The results of measurements are presented in table. Applications are designed to be interacted with by users, therefore the responsiveness is another important metric in terms of performance. One of the possible interactions in the application in question is creation of the new post that causes a HTTP request to the web server and state update as well that causes the page re-rendering. Google Chrome DevTools allows us to measure the exact time for this interaction. The example measurement for creation of the new post action is shown in the picture. The actual consumption time to update state is calculated by using the following formula, where TT is total consumption time and TI is idle time. The results of measurements are presented in table. The average value was taken by measuring the interaction 10 times and afterwards calculating its mean. In this study, two methods of state management in React single-page applications were considered from a performance point of view, Redux and React hooks. A series of tests and measurements were carried out to get a complete picture of how each of the methods affects performance. Redux method requires a lot of boilerplate in order to implement the correct data flow and follow the main guidelines and concepts. In addition to that, Redux also requires the installation of React Redux library as well as a library for creating asynchronous actions in order to make HTTP requests possible. That resulted in worse performance compared to React hooks approach. The study showed that creating the data flow logic is more complex in Redux and takes more code. Also, it took more memory for Redux to store the same amount of data in comparison to React hooks approach. The basic state changing operations consumed more time in Redux method. To sum all up, it can be concluded that React hooks method is more optimized from the performance point of view than the Redux. In case of high importance of application performance, it is not recommended to choose Redux as a state management library in React single-page applications. Further research is required to confirm the results obtained and the conclusions drawn or to refute them. Complex web applications with several entities and additional application-wide state features such as notifications and authorization should be considered for further research. Other methods of state management should be compared in order to provide a clearer picture of the current state of state management in terms of performance. Thank you for your attention. The report is over.